So we are going to cover the NumPy part in class today, and this NumPy part is basically the initial version of starting the data analysis application in the Python. Till now, we were covering the core programming. So now core programming is over. Now some packages will be there for every task. Like first of all, we have NumPy, then we'll cover pandas, and then we'll cover visualizations, and after that we'll cover the EDA. So for everything, there will be few packages will be there which needs to be you need to remember all those packages and all those commands. Okay, so not to worry, we'll cover it one by one. First of all, starting with NumPy. So NumPy is basically it is a Python library which is developed for a large amount of numbers or multidimensional data. Okay, and the advantage of using NumPy is with basically it supports very efficient data storage, and because of that, it is optimized in sequential manner, and this sequential manner allows the numbers to be stored very unique places and confined places, and because of that the entire speed of the calculation gets increased. So I have a small demo that how fast NumPy calculates in comparison to a list. Okay, so here I am creating two functions. Now, how NumPy array has to be created? Don't worry, we'll cover it one by one. I am just importing this import time package to calculate the time. Okay, how much calculation time was there, and then NumPy as NP we have taken, and then size of vector we have taken 10 million. Okay, so 10 million elements are there in array and in the normal list. Okay, so one is pure Python version I am giving, and another one is NumPy version. And what I am doing is I am creating two lists, my list one and my list two, where elements are range in size of vectors. So both array has the elements, 10 million elements are there. Okay, in the same way, we are creating the NumPy array. So to create NumPy array, we have to use np.arange. We'll cover this in a short while. And the same operation is being performed with NumPy array. So when I am doing the list operation, I am adding the elements of list one by one, corresponding element, and for this loop has been applied. Okay, but here for NumPy version, there is no need to apply the loop. Simply we are doing my array 1 and my array 2 addition. And before starting the code, we are calculating the initial time, and then we are calculating how much time has this execution taken. Okay, in the same way here also initial execution time, and then how much time has been taken, and then finally we are calculating how much time has been consumed by both, and finally we are comparing that how much faster NumPy it is. Okay, so I'll run just this part. So this will take some time because 10 million elements are there in two arrays, and both calculations are to be performed. So let's see how fast it is. It will take around 40 50 seconds. Okay, so let this get calculated. And by this calculation, you will get to know that how much NumPy is faster than normal Python. And then after that, I'll show you how it is doing this calculation so faster. So till then this is getting executed, I'll show you something else. I'll open a new file. Okay, and I'm taking I'm creating a list and I'm creating an array. Okay, so I'm creating my list one is equal to, and then I am creating list 45, 67, 89, 33, 24, 79. Okay, like in this list I have taken, and in another block I am converting this list into NumPy array. So um, to convert NP array, NP underscore ARR is equal to um, NP dot A name, and I am taking this till suppose 5,000 I am taking. Okay, so now if I sorry, here I am to do import numpy as np. Okay, so this array is created and one this is it. Now here this calculation is done. You can see here the pure Python version has taken around 74.96 second, around 75 seconds it has taken, and NumPy version has calculated the same in just 1.99 seconds. Means two in just 2 seconds it has calculated. So you can see NumPy version is 37 times faster than the pure Python version approximate, right? Anytime it is not always fixed that it will take this much time only. Sometimes it can take less time, and sometimes it can take higher amount of time. Let's calculate this again. So let this calculate it, and till then we'll see over here. Okay, so I'll print both. Print my list one. Here I'm printing, and here I'm printing print num file. Sorry, print np underscore arr. Okay, so these two list this is list and this is numpy array we have created. Now what we are doing is we are checking how they are getting stored. So let's see print id of my list one comma id of my list one of zero. Then I'm taking my ID of my list one of one and ID of my list one of two. Just this much is sufficient to identify what we want, and the same thing we are applying in NumPy array as well. And just I'll replace the name. Okay, so I have replaced just replaced the name over here, and then we'll see how these are there. So you can see here I have replaced. So you can see here this address is something 201324, and here you can see this is 201228. This is 201288 6. Okay, so you can see here this is these values are at different places. This is 968, this is 152. So these there is no definite location of each element. Although they all are part of list, they are all are sequential connection, but each element is stored somewhere else. Okay, there is no definite location. But in case of NumPy, if you just see, you can see here it is they are located at just one location. So you can see here this is the first element, this is the second element, and this is the third element. All elements are stored at just one location, even not the sequential location. At the same location all the elements are there, right? So because of this, what happens? The compiler don't need to go from one place to other place. Here for calculation with a list, they are going from one place to another place to another place, and this is taking time for the calculation. While this is not true for the case of NumPy, you can see all the elements are at nearby places, all the elements are at same place. Okay, so you don't need to worry that where the number will be. Just you have to pick the numbers and you have to do the corresponding operations, and because of this you can see this speed was this time 57 times faster. So this time the pure Python version took 76 seconds, while NumPy version just took 1.3 seconds. Right. So this may vary based on the occupancy in your system. That's not a issue. But the overall thing, what I need to tell is that NumPy is much, much, much more faster than the normal Python version. And because of that, for most of the number calculation, NumPy is most preferable package for the for Python. Okay, is it clear?
Yes, sir.
Okay, so
Yes, sir.
now here for to import package, we are using this statement import NumPy as NP, and we can create the different dimensional array like one dimension, two dimension, or three dimension arrays, and then, so if we have a list, we can create them. We can convert them into an array. So suppose I have a list, my list, and 1, 2, 3, 4, 5. I am creating. So this my list has been created. Now, if I am going to create the NumPy array from the list, simply what I have to give is np.array. So in this case, also, if I want to create here I have given np.a range, so it will arrange number from 0 to 5. But if I want to convert this list into the numpy array, simply numpy np arr1 is equal to np.array. You have to give this, and here inside this you have to give my list 1. So now this is converted np underscore arr1. You can see now this is converted to the numpy array. Okay, so this is numpy array. You can see the basic difference in look also. Here it is giving 45 comma 67 comma 99 comma 33 comma, so it is giving comma after every element, while here there is no comma between the elements. Okay, so this is how you can convert any list into array. In the same way, you can use the tuple also. If you are creating a tuple and you want to create them into NumPy array, you can use the same dialog, right? So my tup is equal to, and I am creating 543. Okay, and I am converting np underscore arr2 is equal to np dot array, and here I'm giving my top instead of list I am giving. So it is np underscore arr2, and you can see here this is now converted into the numpy array, right? So you can do this with list also. You can do the same thing with the tuple also, but this will not work in case of set. So suppose if you are creating my set, and with my set you have created um 1, 2, 3, 4, 3, 3, 4, 5 I have given, and np underscore arr3 I am giving, and here np dot array, and I am giving my set. Okay, then let's try to print this name np underscore arr3. So you can see here this numpy array is not got converted into say this set is not got converted into numpy array. It is still a set only. So let's check the type. So type of np underscore arr3. So you can see here it is showing this numpy array, but it but it is not giving it the characteristics of the same, because there is a different problem, because tuple and mylist are tuple and list are the sequential data type, but set is not a sequential data type. So and that's the reason it is not giving in same trait. Here there is no comma, but here it is showing in comma. Okay. Now, if you have the two-dimension list, so two-dimension list is like this, right? So you can convert the same into NumPy array. So suppose I am creating this two-dimension list and I'm converting it in the same way. So np dot array, and my mat I have taken, and once I have executed, you can see here it is showing in this way. In two-dimension list, it was showing in the linear manner, but here it is showing the same thing in the matrix manner. Okay, so this you can do, and this is the NumPy array. Okay, so if you want to check the attributes of any NumPy array, so you have the shape function. Shape function returns the attribute, means how many rows and how many columns. So if there is only one dimension array, it will show just one value, right? If it is two dimension array, it will show the value according to that. Okay, then you have to find whether this is a one dimension array or two dimension array. So for that you have to use ndim. So arr dot ndim, and then mat dot ndim, it is showing arr has not been created. Where is arr? I have created this. Mm, okay, now this will work. Yes, and then this mat. So this mat over here, this mat was the two dimension array. So in case of ndim, it is showing 2. Okay, and size shape is 4 comma 3. Okay, so this is how. So but this is how you can check how many dimensions, right, or whatever shape is there. But if you want to check what is the data type of the NumPy array, right? So if you can check using type statements, it will show you NumPy dot nd array, and if you check the d type, so D type will show that whether it is an integer array or this is a string array. Now, in case of NumPy, the string values are also allowed. It is not hard and fast that NumPy will contain the numbers only. If you want to store the strings will also get stored. So, if I am creating like str list, I am taking, and here I am taking um, a comma b comma c. So this is the string list. Okay, I am converting this. So here np dot arr str is equal to, and I am taking np dot array and str underscore list. Okay, I file print now and arr underscore str, and type of arr underscore str. Okay, so you can see here arr str name not defined. Why it is? Oh, sorry. Yeah. Okay, so this is NumPy array, and it is a string type. So if you will check the type, uh, sorry, arr underscore str dot d type, so it will show you that this is not an integer, right? So, basically, in case of the NumPy, you can store any kind of things. But what will happen is if you give a mix of both means suppose I am giving um ARR and ARR NP is equal to NP dot array and now I am giving a list of let's suppose 487 and I'm giving A and I'm giving Palin. Okay, and these things I'm giving. Now if I execute this numpy print arr underscore np, so you can see here I have given two integer and two strings, so it has converted all the values into string. And if I try to check the d type of it, so type this type of um, ARR NP. This is I have taken, and then I am checking ARR underscore NP dot D type. I am checking. So you can see here it is not showing that it is a string. It is an integer. It all are considered as a string. So if you are giving the multiple data type into one, still at that point of time also it will do the it will convert all the elements into the type in which all are convertible. Okay, so you cannot convert the string into numbers, but you will convert the numbers into the string, and that's what it is showing over here. Okay, so this is how you can get. Now, for example, if I have taken arr underscore np is equal to np dot array, and I am taking let's suppose 45.89 comma 54.23, and then I'm taking 67.43 sorry 67 comma 43 and 12 I am taking. So now you can see there are mix of float values and the integer values. And if I try to check the type of each value, you can see here now. You can see here for the values which were not in floating points, for them also it is showing this 43.12 point. This is NumPy array, but the whole type is float. Okay, so basically, the moral of the story is that you can give the numbers in different data types, but the NumPy will convert all the values into a data type in which all are convertible. So if you give any one string, so everything will be converted into string. Okay, if you are giving suppose arr underscore np is equal to np dot array, and here you are giving let's suppose 56 and no, 43 I have taken, then I am taking a boolean value over true. And okay, just I'm taking just these three values, and if I try to print this now, okay, so you can see here, this true is now converted to one. Okay, sorry, this true is now converted to one, and the entire type is integer. But if the same in the same array, if I try to take, sorry, if I'm taking it like this, and here I'm giving a floating point value 78.543, and this I'm trying to execute. You can see here now the entire data is converted to the float, and this type is float. Okay, okay, so this is how you can do it. Just give me 2 minutes. Sorry, there was someone on. Okay. So, is this clear to everyone? I hope this part must be clear. So now we are now going to see the multiple way how we can initialize the array. So to initialize the array, like in normal Python, we were using the range function. So there were multiple variations of the range function. In the same way, here in NumPy, we have a variation of a range. Okay, and the a range does the same job what the range does in the normal Python. Um, Okay, so here like I have defined np.arange, so it is giving me all the values starting from 0 till 14. If I am just giving the range also, so in normal Python there was a range value as well. So if I am just giving the range np.a range and I am giving just suppose 10, right? So it will start from 0 and will go till 9, right? The second variation np.a range, and I am starting from 5 and going till 15. Okay, so it is starting from 5 and going till 15. So this is the variation over here. And then if I'm giving the third parameter, first parameter will be the starting, second parameter will be the ending point, and third parameter is the jumping of steps, right? So 0 to 2, 2 to 4, 4 to 6, 6 to 8. Like that, it is jumping by 2 on that. That is the step size. Okay, then you can, if you want to generate the array of zeros, so you can use zeros function. Then if you want to create the array of ones, then you can use ones also. Okay, and both things can be done in the different dimensions as well. So I am creating zeros into 2 cross 3 dimension. It is getting generated. I am generating array of ones in 3 cross 4 dimension. It is getting generated. Okay, now, something very important, that is linspace. What is this linspace? Linspace is generating certain number of certain number of numbers in equal distant, right? So, for example, I have taken linspace 0 to 10, and between 0 to 10, I have to generate seven numbers. Okay, so now first number is 0 and last number is 10. Then remaining five numbers will be at equal distance from 0 to 10. Okay. So you can see here it is started from 0, then it is 1.6, 3.3, 6.66. So if you will calculate the difference between this and this, it will be same. This and this will be same. So all the numbers are generated at equal distance. Okay. Now suppose if I want to generate the 10 numbers between both. Okay, so you can see here it is giving me 10 numbers. So 1.11, 2.22, 3.33. So first number is 0, last number is 10, and then rest 8 numbers are between this distance, right? Let's suppose I am generating 11 numbers. So you can see here now it is generating 0, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the middle numbers. First number is 0, last number is 10. So basically, little space gives us a equal distant number between a certain given range. Okay. Then, if you want to create the identity matrix, it will create the identity matrix for you. So for that, we have to use the I function, and then dimension you have to give. So it will create a 2 cross 2 array. Sorry, multi dimension array, 2 dimension array, not 2 cross 2. Here I have given 4, so it will generate 4 cross 4 array of identity matrix. And means the diagonal will be um, 1. Okay, so there will be one upper triangle, there will be one lower triangle, and in diagonal it will be 1. So if I give this as 5, so you can see here it is generating the area of 5 cross 5. Okay, whatever value you give, it will generate the value of that value cross that value. Okay. Then if you want to assign some random numbers, so for random numbers we have rand function. So for that, np dot random dot rand function I am using. So now this is generating the 15 random numbers between 0 and 1. Okay, the rand function, the same rand function is there in Excel also, and this rand function is there in this. Okay, so np dot random dot rand, it is generating random numbers in one dimension. If you want to generate the same in two dimension, it will generate in two dimension as well. Okay, so you can see here it we are generating four cross two dimension. It has generated same numbers in four cross two. Then second thing comes is rand n. Then rand n is generating number between -1 and +1. Okay, the rand is generating between 0 and 1. Rand n is generating random numbers between -1 and +1. Okay, so here you can see here it is generating the numbers between -1 to +1. Okay, so this is how you can generate these numbers and you can make use of them. Okay, then apart from that, if like you have to this we have already discussed. Like if we have to assign the non-numeric numbers, what how it will be treated and how it will affect the other values. Okay, we have already discussed. Then NumPy indexing. So NumPy indexing is same as what we have been using in either NumPy list or tuple or sorry, no, normal list, tuple or what or a string. Whatever we were using, the same thing will we can use over here. Same indexing will start from 0 and it will go till um, the number of elements -1. Okay. So for slicing, suppose I want values from 1 to 5 or 8 to last or starting to sixth index. So it is the same that we were using in a normal Python. Okay. If you want to insert in range, so 0 to 5, we want them to assign as 15. So you can see here from 0 to 5, all the values are assigned 15, and after that, normal values are there. So this is so NumPy arrays are totally mutable. Once you have created, you can change anything, you can add anything, you can remove anything like that. Like that, you can perform any operation with your NumPy array. Okay. And then, if suppose you want some pieces in two-dimensional array, so that also can be done. Okay. Then now this part comes. This is important part, which is generally being used in data processing, like applying filters and all. Okay. So we'll see how we can apply. Very easy. It is just one command. So you have to practice all these commands at least once or twice. Then only you will get to know how these commands are working. Okay, it is very important to understand. There is no logic in this, but this requires practicing a lot. Okay, so now let's see. We have suppose I am creating an array np dot a range 0 to 11. So it is giving me an array starting from 0 till 10. Okay. Now what I want is I want all the numbers which are more than 5. Okay. So this I am applying this array condition. Array count is there, and I am applying array count greater than 5. Right. So now what it has done is wherever this condition is true, it is returning me true. And wherever this condition is false, like 0 is greater than 5, false. 1 is greater than 5, false. 2 is greater than 5, false. So wherever condition is not getting satisfied, it is returning me false, otherwise it is returning me true. But I don't want this in this way. I don't want this. I don't want like this. So what I'll do is, what we can do is, we can supply this entire condition into the NumPy array as index directly. Okay. So what this will do is, now suppose I want all the arrays, all the values which are completely divided by 2. Okay. So here you can see, um, inside this array. What I have done is, I have stored this condition into a variable, and I have passed that variable over here. So this variable will apply this condition on each element of array, and the elements which are satisfying the condition are being printed over here. Okay. In the same way, array count I have not executed. Let me execute this. Okay. Now, okay. So now, rather than giving the variable, you can use this entire condition itself as an index. Okay, so what I'm giving is, I'm giving the entire condition over here. Okay, in at the place of index, right? So then also it will act in the same manner, and it will give the results where give the elements where all the elements are satisfied. So in this way you can apply the filters in your data. Okay. Okay, any doubt? No. Any doubt? Okay. So now there are some broadcasting operations are there. So for broadcasting, suppose we are taking two arrays. One is a scalar, two, then this is array 1D and array 2D I am taking. These three arrays I have taken, and now I am trying to apply the operations together with arrays, right? So now, what I'm doing is array 2D and scalar. So scalar value is 2, and this array is 2D. So in this array, what I'm doing is this array divided by scalar. So divided by 2. So what will happen is, this each element of this array will be divided by 2. Okay, so you can see this 1 point, this is 1.5, 2.5, then 1.5, like this. These values are there. Now if suppose I want to implement some in some part only, so like this I can take 1 onwards, then divided by 3. So now this will be implemented in this part only, here, from this place to this place, this place to this place, and this place to this place, right? And then now suppose I have a in previous example, the scale the this value was 4 cross 3, and this value was 1 cross 3. So you can implement, this is 1 cross 1. Okay. Now what I'm doing is array 1 cross 3 and 4 cross 3, right? So there is just three elements, three columns in one array, and here we have four rows and three columns. Now when we are trying to do some operation between this, so array 1D, which is 1 cross 3, array 2D, which is 4 cross 3. So you can see here all the elements of this. Now this 10 is being 10, 10, 12, 14 is being multiplied by 2, 3, 4. Then same, all three arrays, all three 10, no, 12 and 14 are multiplied by 4, 5, 6. So 10 is multiplied by 4, 12 is multiplied by 5, and 14 is multiplied by 14. That's 6. Okay. When we are operating like this, all these elements are being operated with one with this, second with this, third with this, and fourth with this. Okay, so this dimension is supporting. But suppose if you are taking, suppose I have a array of 2 cross 3, and I am trying to apply this, so you can see this is giving me error. Why this is giving me error? Because there is no uniformity, right? Either one, if in another array only one element is there, that can be done. But if there is no definite, like there is 2 cross 3 is there, so in 2 cross 3, this is different, this is different. Okay, so it will not be multiplying or any broadcasting operations together. Okay, so 1 cross 3 will work, 1 cross 1 will work, but any other thing will not work. Okay, okay. So these things are being asked sometimes in form of multiple choice questions in order to check whether you have done these kind of operations or not. Okay, then if you want to supply in multiplication, so you can do these multiplications as well, but the form should be matching. Like here you can see this is 1D array, this is 1 cross 4, and this is 2D array. So 2D array is this, but when we are trying to do some operations like a plus operation over here, it is telling us that this is not possible, right? Why? Because there are four elements over here. There are four elements over here, and here there is only three elements. So, where the fourth element will go? With whom will this get multiplied? It is not sure. So, because of that, it is not allowing us to do any operation. Okay. Then there are some mathematical functions are there in NumPy. So those mathematical functions like minimum or maximum, to find how what is the minimum value, what is the maximum value, we use this. And then argument minimum and argument maximum. So like here we have the minimum argument at this place and the biggest argument at this place. So it is giving us the position of the biggest argument or smallest argument. Suppose, let's say I am taking like NP range, NP ARR is equal to, and I am taking something like um sorry, NP dot array, and here I am taking list as input, and here I'm giving 6, 31, 91, 87, and 93. Okay, I have taken these numbers. If now if I am taking np dot arr, sorry, np arr dot arg min. Okay, and np arr arg max. Right, so it will search for the minimum argument and the maximum argument, and then will print according to that. Okay, so I'll just use this print statement with this, so that it can print both at the same time. So here you can see the minimum element is at this. So its index is 0, 1, 2, 3. It is returning me 3. Right. The biggest argument is this 93. Right. So its position is its index is 5. So that's what it is returning. Okay. So argument min and arg min and arg max are to find the index position of minimum or maximum array. Okay. Um, then you have to find the square root sqrt function. You have to find the mean function. You have to find the exponent values. It will give the exponent value. Okay. So this is these operations can be done. Then there are, if you want to change the structure of any array. So for example, I have created an array from 0 to 15, and I want this to be arranged in 5 cross 3. So you can use the reshape function. So reshape function will help you to change the structure, right, from one dimension to other dimension, right? So reshape functions only work from one dimension to other dimension array. Okay. But when you have to convert the other dimension array into one dimension array, you have to use the flatten function. So flatten function will convert any other dimension array into one dimension array. Okay. Then there is transpose function. You can change the row and column into column and rows. So for that, transpose function is used. Okay. If you want to split the array, so to split the array, now suppose split or merge, let's see. So one array I have array X and another array I have array Y. And now what I'm doing is I am going to concatenate both arrays. So I am using this concatenate function. So let me execute this. And now I will be using concatenating. And then concatenation, we have to see whether the row wise concatenation or column wise concatenation. So when you want to merge it row wise, means once rows of one array are finished, the second array should get attached after that. Okay, so that is row wise merging. So for that I have to give access is equal to 0. Okay, so when I execute this, so you can see here, this is the merge array 1 2 3 4 7 4 5 6 7. After this, you can see 21, 22, 23, 24. Like this, these values are coming. If I'm giving the same thing with the means the concatenation with axis is equal to 1. So suppose if I'm giving the axis is equal to 1, so then you can see here this is being executed like this. Okay. And then the same thing if I want to apply with the splitting. So this was the concatenation, and then now this is splitting. So if I want to if I want to split this horizontal in the sense, now suppose we have a array like this, okay, and I'll convert this into 0, okay, and I want to split this array into two. So one part is that 1, 2, 5, 6, 21, 22, 23, 5, 26, and then second part will be 3, 4, 7, 8, like that. Okay, so for here I'm giving 2, right? So it will divide it into two equal parts. Okay, so it will always try to divide the array into equal parts only if suppose you give at any point of time you give 3. So now four values cannot be divided into three equal parts, right? So it is giving me error. If I give this value as 1, so you can see here it is just giving me 1. If I'm giving this as 4, you can see here it has divided into four equal parts. So this value should be dividing into equal parts, then only it will do. Otherwise, it will not divide. In the same way, I have to use the vertical split. So I can use V split. So for horizontal, it is H split. For vertical, it is V split. Simple. Okay, and then I am dividing. So it is dividing the array in vertical manner. Okay. So this is all about the NumPy. So in NumPy, there are many, we have seen many number related operation, then filters, how filter can be applied on the numbers. All those things we have seen over here. Okay. So basically, the advantage of NumPy is one thing, it is much more faster than the normal execution. So NumPy is basically it can speed up your calculation in the mathematics and all kind of mathematical operations which are available in normal maths function, maths package. The same operations are available in much more faster way with NumPy as well. Okay, so you can do all the number related operation with this. Okay, and then since the NumPy arrays are of fixed size at the time of creation, then you can change any number, but you cannot append any number once the array is created, or you cannot remove any element. You can change element, but you cannot add any element, or you cannot delete any element. Okay. So this is the difference between the normal list and the NumPy array. So sometimes in interviews also it can be asked that what is the difference between NumPy array and list. So you can simply tell that the storage is sequential in NumPy while it is not in sequence in NumPy list. And sorry, normal list. In normal list, you can append, you can extend, you can change any values. But in case of NumPy, only you can change the values, but you cannot append any new value into the NumPy array. Once it is created, it is done. Okay. Okay. Clear to everyone? Okay. I covered this in last class as well. I have just give you repetition of all those concepts because it has been big gap. So now in next class we'll start with the pandas so that you can start working on the data files as well.